All right, greetings, my darling period 5. I want to start off by first telling you guys I am so proud of you. You guys are working hard. I know some of you have been sick and you've been out, but I see you, and I'm here for you. Remember, Tuesdays and Thursdays at lunch, I'm here for you. So if you need that extra support, that extra kick, come see me. No, I won't kick you, but I will definitely give you the support that you need. All right? Okay, so here we go. Last lesson for transformations. Lesson 4, we're talking about transformations with square root parent functions. So take note that you cannot take the square root of a negative number. We discussed this in class. It doesn't exist within real numbers. It does exist with imaginary numbers, but we'll talk about it later at the end of the semester. For now, consider the equation y equals the square root of x. This is our parent function. And if we were to plug in a 0 for x, we would get the square root of 0, which is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. Which is why we chose perfect squares. Nick had said in class that these are perfect squares. Okay, so in our parent table, we have parent coordinates. When we go to plot these coordinates, this is what our parent graph would look like. Notice that you have a vertex at the origin. Notice how my line, when graphed, does not go beyond it. It does not go below it. It does not go anywhere. It starts at the origin. And when we plot our other points, we see that it takes off up and to the right. Don't forget your arrowhead. You must have your arrowhead. You must have your arrowhead. All right, so when we take a look at the domain goes from 0 to positive infinity. Your range, it goes as low as 0 along the y-axis and takes off to positive infinity. Now, when we take a look at the equation for square root transformations, we see our good old a on the outside times the square root of x minus h plus k on the outside. So notice that what's in pink are vertical changes. What's in blue is a horizontal change. So your starting point is always going to be 0, 0 for your h comma k. So once again, we're going to take a look at our transformations. Our transformations will always be the same within our grouping symbol. So you can consider parentheses a grouping symbol. Absolute value is a form of grouping symbol. Your exponent, so whatever's happening to x as an exponent, is also a form of a grouping symbol. And now your radical sign is also a form of a grouping symbol. So when you take a look, this is not that. Your radical sign does not extend above plus 3. Your plus 3 is your k value on the outside. And whatever happens on the outside happens to your y, because y is your vertical axis. X is your horizontal axis. So we're going to start with our parent table, 0, 1, 4, and 9. 0, 1, 2, and 3. Let's go ahead and describe the transformation. The first transformation I'm going to talk about is the horizontal shift. I'm going to abbreviate and I'm going to move quickly here. If I'm going too fast, you can stop, pause, rewind. Horizontal shift to the left by 2. Our other transformation is a vertical shift up by 3. We obey the sign. So whatever's happening to x, we do the opposite. Whatever's happening on the outside of x, that is happening to y, we obey the sign. So here we go. I'm going to go ahead and subtract 2 from my x values. And I get negative 2, negative 1, 2, and 7. Next, I'm going to add 3 to my y values because it's a shift going up, I get 3, 4, 5, and 6. So your starting point, your new starting point, is going to be at negative 2, 3. And we're going to plot these points, negative 2, 3, negative 1, 4, 2, 5, 7, 6. I'm going to go ahead and graph that curve. Notice that my starting point is at negative 2, 3. Nothing goes down or below. That's a romper room no-no. This is your starting point. Nothing goes beyond that except your next points above and to the right. So your domain, your new domain, is now negative 2. Put a bracket around it, and it takes off to positive infinity. Positive infinity. And your range, it's as low as positive 3. Put a bracket around it, and takes off to positive infinity along the y-axis. Let's try it again. Next page, number 2. Easy peasy, lemon squeezy. 0, 1, 4, and 9. 0, 1, 2, and 3. Those are your parent values in your parent table. Let's go ahead and describe the transformation. First and foremost, we have this reflection. Reflects over x-axis. And then we've got this, we've got this guy. Horizontal shift to the right by 3. Horizontal shift to the right by 3. And last but not least, we've got a -1. This will be our vertical shift down by 1. So let's do some math. Make sure your math is mathing correctly. To our x's, we are adding 3. It's to the right by 3, so we're adding 3. 3, 4, 7, and 12. The reflection means we are multiplying by -1. Since it's happening on the outside, we're doing it to our y value 4. And voila, folks, here are your new x and y coordinates. So your starting value, your starting point, is at 3, -1. So I'm going to plot these points. 3, -1. Oops. 4, -2. 7, -3. And 12, -4. I know, it's right down here, right at the edge. And notice how, because of that negative sign, we've got a reflection over the x-axis. This is curved down and to the right. Don't forget your arrowhead. Down and to the right. Because of the reflection, there is a curve down and to the right. Make sure you're graphing correctly. So your domain is from 3, bracket around the 3, to positive infinity. And your range is from negative infinity. How low does it go? Negative infinity. How high does it fly? It goes as high as -1. So make sure you put your bracket. Remember, this change happens because of that reflection, that negative sign out front. That's why there's a flip. Okay. Notice how there are no asymptotes, nothing. Okay. We're going to go on to number 3. I'm going to move quickly now. Again, I have 0, 1, 4, and 9, 0, 1, 2, and 3. Folks, I am not doing anything to my x values because if you look under the radical sign, x is just chilling like a villain by himself. So I'm just going to address the 2. I'm going to multiply, because that is a vertical stretch, multiply my y values by 2. This gives me a 0, 2, 4, and 6. And next, I'm going to subtract 3 from my y values. This is towards my y values because it's happening on the outside of the radicand. So minus 3. This becomes negative 3, negative 1, 1, and 3. So here we go. I'm going to plot some points. My starting point is at 0, negative 3. Here we go. There it is. 1, negative 1. You see that little double stretch we've got going on? 4, 1. And finally 9, 3. So you can see our parent function stretched by 2. Make sure you write your arrowhead. Folks, this is our starting point. So notice how nothing goes below that. Do not do that. Square roots do not have that. They have a starting point. Remember, we cannot have arrowheads at both ends, only on one end. So your domain, it goes as far to the left as 0, as far to the right as positive infinity. Your range, it goes as low as negative 3 and as high as positive infinity. Okay, let's do it again. One more time. Number 4. We've got a reflection and a shrink, so get ready for some wonky numbers. 0, 1, 4, and 9. 0, 1, 2, and 3. We have a plus 4 under the radical sign, so I'm actually going to subtract 4 from my x values. This becomes negative 4, negative 3, 0, and 5. Next, I see I've got a negative sign here, so I'm going to go ahead and multiply a negative 1 to my y values. Take care of that reflection over the x-axis. Yes, I know we have to go back and describe the transformations. We will do that in class. Actually, you should do it on your own, and we'll cross-check it in class. Here we go. 0, negative 1, negative 2, and negative 3. And finally, we've got this shrink, vertical shrink. That means I'm multiplying my y values by a 1/2. Well, Miss K, couldn't I have just multiplied by a negative 1/2? Indeed, you could have. I just had a brain fart moment and kind of forgot to do that. So I'm just going to do it now. This is a 0. Let me go ahead and make this a negative 1. This becomes a negative 1/2. This becomes a negative 1. And this becomes a negative 1.5. So my starting point is going to be at negative 4, 0. There's my point. Then negative 3, 5, negative 1.5. Right there. Yeah, that's a really squished up square root graph. So notice how it curves down and to the right. You need your arrowhead. Nothing goes past this, so don't do that. And now we can state our domain. It goes as far to the left as negative 4, including negative 4, as far to the right as positive infinity. Your range goes as low as negative infinity because of this negative sign in front, and it flies as high as 0 along the y-axis, bracket around the 0. Now, your objective here is to go back and make sure you describe the transformations in words in order for numbers 4, 3, and 2. We did it, no, 2 we did together. Did we do 1 together? Yes, we did 1 and 2 together, so you need to do 3 and 4. And that is all. And make sure you complete the practice. It's due on Friday.